This is problem 118 of Neetcode 150, distinct subsequence. So we're going to be giving two strings S and T, and they're both going to consist of English letters. And we're going to have to return the number of distinct subsequences of S which are equal to T. So for example, in here, we have the first string, which is cat with 3A, and it is cat with a single A. So you can basically use the first C, and you're going to have to use the first C in each cases, and the last T. But then you have the choice to pick between one of the 3A inside the cat with 3A's to complete cat. So it doesn't really matter in which, well, it matters in which order the letters of cat appears in the long cat, but it doesn't matter if there are like some noise between the letters, like these double A's or this A and this A after it, or the double A here. This doesn't really matter. Same thing here. So you have X, X, Y, X, Y, and we want to compose X and Y. So there are a couple way, right? Because we know that we have couple X's and couple Y, so we can just pick a combo of X and Y that where the X appears first and the Y appears second in the long X, X, Y, X, Y. And this is going to give us the correct solution. So today I will give you the optimal solution, and I will do this in 2D dynamic programming. So first thing that I want to do is that I want to create a grid like this, and I'm going to initially put zeros everywhere, except on the right column. In this right column, I'm going to put ones, and you will see why later it is helpful for us. And I'm going to do a bottom-up approach. So I will start from the bottom right row. And I will also, I will go up to the top left. So that's our setup. The first thing we're going to do is that we're going to place ones on the right column. And notice that we also have an extra row and an extra column. This is done on purpose. So what we're going to do is that we're just going to go on each cell. We're just going to pick up what is the number of the cell that is right under it. So this way we can keep track of, because what we want to do is that we want to basically carry like a 1 here from the T, because we know that there's one way to actually we have one matching characters here, and now we know we have another matching characters here. We have our 2 A's, so but we're still going to be at 1 because we didn't create another way. We just know that in this path, well, we think that so far we can actually make up the string that is vertical with we can make up the horizontal string with the characters in the vertical string, but we didn't find like a second distinct path for that. But then when we're gonna meet this second A, we know that we can actually have like another option here, because we can pick between the two A's, and in both cases it will make up the cat word. So now we want to carry our 2 here, and now we're going to carry a 3 here because we have another A, so it's another possibility of creating the word cat. And then we have a C, which is matching the first C of the small cat. So now we're just going to carry our 3 up here, and this is what we're going to send as the answer. But to do so, we have to always take a look at the value that is right under it, and we're going to have to set that cells equal to the value that is under it. And then if we have a matching characters like T and T here, they're both matching characters, well, we're just going to add to this value, which is 0, the cell that is diagonal to its cell. So we're going to take like the previous characters for both words. So in this case, we are going to be having the value 1 in that bottom right cell. And now we're going to continue here. So we're going to go see the next cell. And once again, we're going to set its value equal to the cell that is under it. And unfortunately for us, the two characters here are not matching. We have an A and a T, so we are not going to take a look at the cell that is diagonally down to it. So we're just going to move forward again. We're going to go see this case. We're going to take a look at the value that is under it and set its value equal to this. And we're going to take a look at the two values, or the two characters, but they're not equal, so we're just not going to care much about it. And now we are going to take a look at this cell, right? We're going to keep going our bottom-up search, and we're going to realize that, well, we're not going to realize, but we're going to set its value initially equal to the value of the cell that is right under it. So it's going to be equal to a 1 initially. Now we want to take a look at whether or not the two characters are matching. We have an A and a T, which is not the same character, so we're just going to move. So we're going to go here. Once again, we're going to pick up the value that is down, which is a 0. We're going to check if the two values are matching, and they are actually matching. So what we're going to do is we're going to add to the current value, which is 0, but whatever that value is, we don't really care. We're going to add the value that is diagonally to it. So it's going to be set to a 1. And then we're going to move. We're going to go here. Again, picked up the value under this. It's a 0. Are they matching? No. So just move on. And now we're going to be here. We're going to pick up the value that is under it. So it's going to be a 1. And is A and T matching? No. So we're just going to move. And now we're going to go here. We're going to pick up the value that is under this. And notice that this is where the algo starts to be quite useful, because now we are, as I shown in the example, we are carrying a 2 here, because we know that with our second A, we have now a second way to create cat, right? Because to make cat, we have like the choice to pick this A or this A. So this is why we have a second option to our problem. And we have it 2 basically because we initially picked up the value of the cell under it, which was a 1. And now we notice that the two characters at these positions are matching. So we just added to this one the value of the cell that is diagonal to this. Because the value of the cell that is diagonal to this is always going to carry like the previous number of options that we have. So I think that you can start seeing the pattern here. The next cell that we're going to care about is the cell where the other A is matching. So at this cell, we're going to pick up initially the value of the 2 here. So this is good, right? We're picking basically the number of options that we had so far. And since they're matching, we're just picking that one value that is diagonally down to it. So it's going to be set to a 3. And I think now you can see it right away that when we go to this C, we know that we have matching characters. So we just want to pick up that diagonally down value. So it's going to be 3. And this is what we are going to return, because there are 3 ways to create cat, that long cat that has 3 A's. Notice that we're also going to have a 3 here in this case. It's not a big deal, but we're going to have a 3 here, because we're going to pick up this value that is down. But I hope this makes sense. We're basically just always picking up the value that is down to it, because we know that by doing so, right, like at this particular A, by taking the value down, we're going to know if there's basically another character that is exactly similar to this A, right? Because now if we take a look at this first cell where we have 2 C's, and we go C1 cell down and we have another A, it doesn't really work, because what we're willing to have is a character that is exactly the same as the character of the column. So now what we're doing here, when we have our first A, we're just seeing if we have another options for our A. So can we basically, is there another A? And if they're matching, there will be basically a count, and this count will tell us how many other options we have. So we know that with our 2, we have this option itself, and we have another option down there, which is going to be a 1. And then once we reach the T value, which is not the same character as the A, we now have a 0. So I hope this makes sense. And then the reason we're picking up the value that is diagonally down to this is because once we have 2 matching characters, we can move our cursor. Like let's say that we have our cat here. and we have our long cat. All right. We know that initially what we will like to do is to have like our 2 pointers here and check if both characters are matching. And when they match, we just scratch them. And then um, we can take a look at the other characters and see that they are matching. So we're just going to scratch, we're just going to scratch the character of the long string. And then we're going to put a pointer to the next character, see if it matches again. And that's basically what we're doing here when we take the value that is down. We're just going to pick up the next character of the long string to see if it still matches. And as long as it matches, we're going to go one down. So now we will have to basically have like two call and see if they match again and again and again. But what we're doing here is that the value that is down, we know that it's gonna tell us basically how many other values we can we will match basically the current value A. So this is why our 2 is basically saving us. And now we can scratch this, we can scratch this, and now we can basically move to the next value, which is a T. And that's pretty much what we're doing here when we go diagonally down. Like for example here, when our first let me just pick another color. When our two A's match there, we wanted to take a look at the other two characters, which end up being T and T, and see if they matches. If, for example, they are not matching, we will not have picked up that value that is diagonally down. We'll have only picked up that 0 value, so this will have been a 0. Hence, this will also have been a 0, because even though like the two A's are matching, the rest of the string is not matching, so it is not going to work, and it is not going to make up a substring. So this is, I hope it somehow makes sense. And now we are going to have to code this. So the first thing I will do is that I will create 2 variables just to hold the length of the 2 strings, because we're going to use them quite often. So I think it is convenient for us to have just smaller variable than having to create len s and len t each time we want to take the length of these strings. So this is the first thing I want to do. And now I'm going to create my 2D grid. So it's going to be a couple zeros. And notice that the length of the length of a row, it's going to be the length of the smallest string. And the smallest string here is the second string, so it's called t. But we store the length of t as the variable n, sorry. So we want to have 0 times n plus 1 because we are creating an extra column. And you want to add this for basically the length of the long string, which is s, but this len is stored as m, and you want to have an additional row. So this is the setup, and now we want to basically set the far right column to be entirely made up of 1. So I will say for basically I in the range of m plus 1. So m is the number of rows. I will say that the dp at this particular row and at the very last column is going to be set to a 1. So now we have our far right column made up of 1s. And what I will now do is that I will create my 2 for loops, which will compose the bottom up dynamic approach. So I will have for r in the range. And now I will add 3 values in this. The first value will be the index I want to start at, and I want to start at the very last row. So I will say m minus 1, and I want to have 2 minus 1 that follows this. The first one is going to specify the bounding index. Since we're doing a reverse order, which is identified by the third minus 1, which makes it go in a reverse order, we're going to have to create a bounding index ourselves. And since we want to go up to the index 0, we'll let the bounding index be the index minus 1. And I will do the same thing. So now I have my for loop for the row, and I want to do this for the columns as well. So first in the range of, and same thing here, n minus 1, minus 1, minus 1. What I want to do is that I want to set this cell. So in the DP that we created, this cell at this row in this column is going to be equal to the cell that is under it. So it's going to be row plus 1, but it's going to stay in the same column. And now we want to check if the two characters are matching, and only they're matching, we're going to add to this cell's value the value of the cell that is diagonally down to this. So if string, right, so the index R is going to basically represents an index along the string S, and the string S is the longest string. So if S at the index R is equal to T at the index C, then we want to basically say that TP row C is incremented by the diagonally down, so row plus 1 and column plus 1. And that's it. So now we can return the top left cell inside our DP, and this will give us the answer. So let's test this out, and this works. Awesome. So notice that our time and space complexity are going to be the same here, and the reason is that for the space complexity, that's probably the most obvious part. We are creating basically a grid that has the dimensions of the two strings. So let's say that well, our space complexity is going to be m times n, right? Where m is the length of S and n is the length of T. And in terms of time complexity, well, we're going through every cases one by one. So we are also going to have a time complexity of big O of m times n. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.